Okay, so we just set up problems 1 and 2 on the page 1. Now what I want you to do is scroll all the way down to page 4. Notice it also has problem 1 on page 4. Now I don't want you to do any of these problems on your own just yet. We're just going to be doing these together. I'm going to give you practice, as always, to be doing these on your own. So once again, what I want you to do is just follow along with me on problem number 1 on page 4. All right, so it says you exert a 98 Newton force on a 25 kilogram box. What is the resultant acceleration of the box given the coefficient of kinetic friction is 0.2? And we have an answer over here. Okay, so what are we doing? It looks like that we're just simply exerting a force on a box, and we're trying to find out what the acceleration is given this coefficient of kinetic friction. Okay, so let's just draw out our free body diagram. So we have our box over here. What are the forces acting on it? You should know this by now. It says that we're exerting a force onto the box. It doesn't really sound like that we are explicitly being told that we're pushing or pulling the box at all. Let's just say that we're pushing the box to the right. Okay, what kind of force is that? And is there an opposing force? Okay, it's a frictional force, right? What kind of friction is it? Well, first of all, it says it's asking us what is the acceleration of the box, so we know it's in motion. Also, we're being told a coefficient of kinetic friction is 0.2, so we know that the box is in motion. That's enough hints for us to tell that our box is moving, so therefore we're dealing with a kinetic friction as opposed to static friction. Okay, and that looks like our free body diagram is all set up right now. So let's go ahead and pull out the given information. It says if you exert a 98 Newton force. What is that 98 Newton force telling us? What kind of force is that? Okay, and what is this 25 kilograms telling us? All right, and it's asking us what is the resultant acceleration of the box. So that's simple enough. We know that that's going to be acceleration in the x direction is what we're looking for. And the coefficient of kinetic friction is 0.2. All right, and once again, coefficient of friction, those don't have any units whatsoever. All right, and being that we have the mass of the box, we can figure out the force due to gravity acting on it. All right, and now let's set up our two force equations. Okay, so what we're going to do here is say that all the forces going upwards are going to be our positive forces, and all the forces acting to the right are going to be our positive forces. Why did we say to the right? Well, if we're applying the force to the right, we know that that's going to be the direction of the object's motion. It's going to be to the right. And that's the reason why we said that the positive direction is to the right. If the object was moving to the left, we would say that the left is our positive direction. We're defining this. Okay, so all the forces going upward are positive, so therefore we know that the normal force minus all the forces going down is equal to our mass times acceleration in the y direction. Is our object moving up or down at all? No, right? So therefore, what is acceleration in the y direction? Well, if it's not moving up or down at all, how could it possibly be accelerating up or down? It's not. 0 times any number is equal to 0. All right, and all the forces in the x direction, all the forces moving to the right minus all the forces moving to the left. Is equal to mass times acceleration in the x direction. Is our object accelerating? Well, yeah, you know what? That's actually what we're trying to find. So we do know that in this problem, we do have an acceleration. So I can't say that that's 0. That wouldn't make any sense. We only say it's 0 if the object is not moving in the x direction or if we're moving at a constant velocity. So we're just going to drop this down. And this is the setup for this problem.